Okay, here we go with lesson 2 of the transformations unit. So recall a vocab word from the previous lesson. A transformation where the pre-image and the image are congruent is called an isometry. Bringing this up because that word is in the definition of the next 2 transformations. So a translation is an isometry, there it is, that maps all points of a figure the same distance in the same direction. Now, we've talked about something that had distance and direction. We didn't call the distance distance, we called it magnitude. We looked at, in Unit 8, vectors, which have magnitude or distance and direction. Therefore, to describe a translation, we're going to use vectors. Okay. How? Now, the notation is what gets people a little bit confused, but this is actually pretty simple. A vector is made of components. You may remember that back when we did it. The component form, it had those, it wasn't quite parentheses, it was more of a inequality symbol, but it's not an inequality. MN, and that just means those are the 2 components of the vector. The M represents horizontal change, so left and right. Probably guess what the N means. Be vertical change, so up and down of a specific point. We say that the vector MN maps each point, each point has coordinates x, y, to a resulting point. And that resulting point would be x plus m, y plus n. Now that looks really confusing. And I'm not going to make it any better here in a second. Right here. So what you're going to see is each point maps to a new point. And the new point has increased by m and increased by n, is what that means. So the vector -3, 4, okay, means each point, xy, maps to x -3, y plus 4. Again, what does this mean? It means that each x value of the image, remember the image is the ending figure. So each x value of the image is 3 less than the x value of the pre-image. And similarly, each y value of the image is 4 more than each y value of the pre-image. So you're probably still a little bit confused. If you see it happen though, you're going to be like, oh, it's really not that bad. So use the rule that's given here. Each point maps 7 to the right, right? That's what x plus 7 means, 7 to the right and 1 down. So I'm going to stick with the same thing I did with the last lesson. Blue is my pre-image. So I'm going to plot those points, -6, -1. And then -1, 0 is G. And then N is left 4, down 3. All right, so I'm going to go ahead and draw that triangle and label it W, G, N. Okay, now I'm not reflecting it over a line like I did in the last lesson. I am now just moving each point the same distance and the same direction. So what is that distance and direction? Well, it's 7 to the right and 1 down. So from W, I'm going to go 7 to the right. 1, 2, 3, 4, 5, 6, 7. And then I'm going to go down 1. Now I know what this shape's going to look like. It's not going to turn at all. It's not going to be opposite orientation. So I know where I can put my W and not have it be in the way. That's my W prime. G, same thing. 1, 2, 3, 4, 5, 6, 7, down 1. and that's G prime. And then N, the same thing. 1, 2, 3, 4, 5, 6, 7, down 1. And that's N prime. Connect the dots, and you've got your translation. Okay, so that is pretty simple. At least I hope it was. It was a matter of, honestly, counting and plotting. Okay. Yeah, I mean, I could have shown you the coordinates of the resulting points, which I probably should have done because I did last lesson. So W prime, you know what? I could probably pull them back up here real quick. Yeah, there they are. W prime is 1, -2. And let's just look. -6 plus 7 is 1. -1 minus 1 is -2. -1 plus 7 is 6. 0 minus 1 is -1. Is G prime at 6, -1? Yeah, yes, it is. And then N prime, -4 plus 7 is 3. -3 minus 1 is -4. Is N prime at 3, -4? Yes, it is. Okay. All right, to the back. Find the vector that describes the given translation. So basically, point, like number 1, point Z is going to point U. What vector moves it there? Well, what's the horizontal change? Well, it goes over 1, 2, 3, so 3, and up 1, so 3, 1. That's all you're doing with that. Okay, so 3, 1 was this one. Y to W, well, I'm going to the right, 1, 2, 3, 4, and I'm going down 2. Down 2 is -2. Okay, U to V. So a lot of people are going to go down first. Make sure you always go left and right first. So U to V, I'm going to the right 1. And then I'm going to go down 1, 2, 3, 4, 5. And there's my vector. X to W. I don't have to go right or left at all. So that's 0. And then I go down 1, 2, 3, 4. It is possible to have a 0 in there. And then V to Y, I go left 1, 2, 3, 4, 5, 6. Left 6 is -6. I didn't have to go up or down at all, so 0. Okay, a point is mapped using the vector 2, -6, and the image is W. What is the pre-image? Now, this was making you think backwards. So a random point on here that's not plotted. Okay, so I don't have a point that is plotted, or maybe I do, and I'm not telling you where we're starting. I'm telling you where we're ending. When I say the image is W, we are ending here. And we ended there after going right 2 and down 6. So I kind of have to undo that. So how do I undo that? I go up 6 and down 2, or sorry, left 2. So up 6, 1, 2, 3, 4, 5, 6. And then left 2, 1, 2, I am Z. And just to make sure I got it right, start at Z and go to W. What's the vector? Right 2, down 6. There it is. So you kind of go the opposite direction. Okay. Last thing with translations, really not much different. It's just another way of what you might see. Find the image of the point under the translation given by the vector. So I'm giving you the vector this time and 1 point and telling you to find the image. So the resultant. So -1, 4 means left 1, right, or up 4. Left 1, 1, 2, 3, 4, up 4. And we're going to call that A. What are those coordinates? Left 5. Notice the coordinates, I do have parentheses. Left 5, up 6. So -5, 6. Back to the original point. So we're going back to that black dot. 5, -3. So 1, 2, 3, 4, 5 to the right. 1, 2, 3 down. That's B. Okay. that would be 1, -1. 0, 2. So I'm not going left or right at all. I'm going up 2. That's C. And that has the coordinates -4, +4. Notice coordinates come from the origin. Vectors move from the given point. 10, 4. So right 10. 1, 2, 3, 4, 5, 6. Still on the graph, and then up 4. 1, 2, 3, 4. And that lands me at D, which is at the point 6, 6. Okay. Write the vector that would map the given point to the origin. So I want to land here. What vector would I need? Kind of what we did in the last problem. Right 4, down 2. Okay. And that's translations. Last one for this year is going to be rotations, and that's the next video.